Hi guys, ang pag-uusapan naman natin sa videong ito is the introduction to the Runge-Kutta methods. At the same time, i-insert na natin yung second order Runge-Kutta methods. Okay? So, what are the Runge-Kutta methods pala? So, according dito, the Runge-Kutta, or it is abbreviated na lang as the RK method, is an effective and widely used method for solving the initial value problems of ordinary differential equations. So, this method can be used to construct high-order accurate numerical method by function self without needing the high-order derivatives of the function. So, depending on the number of intermediate iteration, RK methods can be in second, third, or fourth, or higher orders, no? So, itong iteration na to, or itong intermediate iteration na to, may intindihan nyo to kapag na-discuss na natin yung mga orders, okay? It can be nga second, third, fourth, or sometimes higher. It can be a fifth, sixth, pero yung widely used lang are the second to fourth order RK method. So, yun lang din naman ang i-discuss ko sa playlist na to. So, let's start discussing this by using or by introducing the second order RK method, or ang abbreviation doon ay RK2. So, ganun lang. Syempre, maintindihan nyo na pagdating sa third order RK method, that is RK3. And fourth order RK method, that is RK4. So, dito, the second order RK format is written in the form, so y sub n plus 1 is equal to y sub n plus h, the quantity a sub 1 k1 plus a sub 2 k2. So, kaya to natawag na second order kasi dalawa yung k. Okay? So, ngayon, yung k sub 1 is equal to f of x sub n, y sub n, and yung k sub 2 is equal to f of x sub n plus p1h, tapos y sub n plus q11 k1h. So, medyo nakakalito yung mga variables dito, pero actually, hindi naman na siya masyadong confusing once na may example tayo dito. So, may apat tayo ditong constants na i-consider, yung a sub 1, yung a sub 2, yung k sub 1, saka yung yung p sub 1, saka yung q sub 1, 1. Kasi, yung k sub 1 and k sub 2 are already defined naman. So, itong apat na unknowns natin, or itong apat na constants, are related by these three equations. According doon, dapat daw yung a1 plus a2 ay equal sa 1. At the same time, yung a2 multiplied by p1 is equal to 1 half, and yung a2 multiplied by q11 is equal to 1 half. Ang problema kasi dito, class, no? Meron kang apat na unknown, pero tatlong equation lang. So, in other words, hindi mo kayang masolve yan dahil insufficient yung number of equations. So, ano ang ginagawa dito sa second order RK methods? Kasi hindi lang ito isang approach. There are actually several approach, and you can invent another second order RK method kung gugustuhin mo, but in reality, tatlo ang most common na second order RK method, and it depends on the assumption ng value ng isa dito sa apat. So, pwede kang mag-imbento or mag-assume ng value. Ang pinaka-common na ina-assume is a sub 2. Kasi once na alam mo na yung value ng a sub 2 class, malalaman mo na yung value ng a sub 1, malalaman mo na yung value ng p sub 1 and ng q sub 1, 1. So, yun nga. That is very random. Okay? Pero ulitin ko, tatlo yung common na ginagamit na second order RK method. And doon sa tatlo na common na yon, yung dalawa ay familiar na sa inyo. So, i-discuss ko siya. Yun na nga, as I said, note that the constant can be solved because there are only three equations relating them. Thus, some engineer assume the value of one constant then solve for the value of the other three using the equations. So, however nga, the most common variation of these methods are, so yung una, the Heun's method, yung sumunod is the midpoint method, and yung pangatlo is the Ralston's method. Yung unang dalawa, which is the Heun's and the midpoint class, yes, tama kayo. Ito yung na-discuss na natin kanina as the modified methods or modification of the Euler's method. So, yung palang dalawa yon is galing din naman sa second order Runge-Kutta method. Okay? So, ngayon, i-discuss ko kung ano yung pinagkaiba pa rin nitong tatlo. So, unahin ko na si Heun's method. According to this method, si Heun's, inassume niya na yung a sub 2 is equal to 1/2. Kaya, ang magiging itsura natin sa method na to, so yung values ng other three constants, yung a sub 1 is equal to 1/2, yung p sub 1 is equal to 1, and yung q sub 1 is equal to 1. Kung isa-substitute nyo yan doon sa general format natin ng RK2 formula, so y sub n plus 1 is equal to y sub n plus h, 1/2 k sub 1 plus 1/2 k sub 2. So ito na yung magiging formula natin. Where k sub 1 is equal to f of x sub n y sub n, k sub 2 is equal to f of x sub n plus h y sub n plus k sub 1 h. So yun na yung mangyayari kapag Heun's method. Again, kay Heun's method, inassume niyang yung a sub 2 is equal to 1/2. So, proceed tayo sa midpoint method. So, for the midpoint method naman, inassume niya class na yung a sub 2 is equal to 1. So, therefore, ang ating constants, yung other constants ay, yung a sub 1 is equal to 0, yung p sub 1 is equal to 1/2, and yung q sub 1 is equal to 1/2. Pag sinubstitute nyo yan doon sa original RK2 formula, ang kalalabasan na lang is y sub n plus 1 is equal to y sub n plus k2h. Where ang k sub 1 pa rin kailangan as f of x sub n, y sub n, pero yung k sub 2 na natin ay equal sa f of x sub n plus 1/2 h, tapos y sub n plus 1/2 k1h. So, ito na yung ating midpoint method. And lastly, ito yung bago, the Ralston's method. So, sa Ralston's method, inassume class na yung a sub 2 natin ay equal sa 2/3, sorry. So, therefore, when we substitute a sub 2 is equal to 2/3, yung other constants natin are, yung a sub 1 magiging 1/3, yung p sub 1 is magiging 3/4, and yung q sub 1 is equal to 3/4. Kaya ang magiging bagong itsura ng second order RK formula natin ay ito. So, y sub n plus 1 is equal to y sub n plus h, the quantity 1/3 k1 plus 2/3 k2. Where, of course, yung k sub 1 is equal to f of x sub n, y sub n, and yung k sub 2 natin ay equal sa x sub n plus 3/4 h, then y sub n plus 3/4 k1h. So, ayun siya. Ang i-discuss ko lang for the next video, kasi i-end ko na to dahil sobrang haba na, is the Ralston's method. Kasi, yung Heun's method and yung midpoint method are already discussed na in the previous lesson. Okay? So, tututok na lang tayo dito. Kaya lang, gusto ko lang i-point out, ito ay family of numerical methods. So, kumbaga, magkakapatid lang si Heun's, si midpoint, saka si Ralston's method. So, yung accuracy nilang tatlo class ay hindi nagkakalayo. Okay? So, most likely, pwedeng mas accurate yung isa. So, depende yan sa differential equations. But generally speaking, hindi nagkakalayo yung accuracy nitong tatlo dahil lahat naman sila ay kabilang sa RK2 or the second order Runge-Kutta method. So, yun lang. The next video nga, i-discuss natin is one example for the Ralston's method. So, i-end ko na to. Thank you so much for listening and watching, and ingat sa lahat.